9 centuries ago, the architects of ancient Bhubaneswar engineered a self-sustaining climate system. They understood precisely how their specific geography processed water and heat. These stone structures served a dual purpose. They functioned as the heavy anchors for a massive network of ecological tools. The city's founders threaded bonda tanks between sacred groves and aligned their streets to maximize the cooling power of prevailing southwesterly breezes. They utilized stone-walled pokharis to funnel monsoon rains directly into the native laterite aquifer, keeping the tropical air naturally cool. For 12 centuries, ancient Bhubaneswar operated as a climate-resilient machine, regulating its own temperature and hydrology through integrated engineering. Over the last 25 years, the modern city systematically dismantled that natural infrastructure. The interlocking system of canopy, water body, and permeable soil was severed to make room for expansion. Satellite data confirms this collapse. From 2000 to 2025, vegetation shrank 89%, while built-up surfaces expanded 83%. This triggers physical failures, a 1.8-degree heat island gap, and a compromised drainage network causing severe flash floods at 12 recurring bottlenecks. The city is now spending millions to import technological solutions for a crisis caused by ignoring its own inherent geographical superiority. Global cities are spending billions to engineer resilience. Singapore has invested heavily in vertical greening and complex water-sensitive urban design to manage its 2,400 millimeters of annual rainfall. Singapore must build artificial filtration systems to mimic nature. Bhubaneswar already possesses native laterite geology, a natural filtration system capable of absorbing and cleaning 1,400 millimeters of rainfall every year. Copenhagen has constructed expensive cloudburst parks designed to pool floodwater. These plazas convert a flood liability into a public asset through high-cost engineering. Bhubaneswar's low-rise residential fabric allows ground-level interventions, like bioswales and infiltration pits, to be 4 times more effective than in the vertical cities of Europe. The world's wealthiest cities are using technology to recreate biology. Bhubaneswar simply needs to uncover its existing geology. Rotterdam builds multi-million-dollar high-tech water plazas to mitigate flood risks and create public value. Bhubaneswar already has a superior pre-engineered version. The ancient pokhari and temple tank network serves as a massive water bank. Restoring these existing sites costs 70% less than building new concrete plazas. Curitiba, Brazil became a global model by integrating rapid transit with green corridors. Bhubaneswar's compactness, covering just 485 square kilometers, removes the need for sprawling multi-decade expansion projects. Because the city's infrastructure needs are geographically concentrated, a fully integrated transit system is achievable within a single municipal budget cycle. Medellin utilized urban acupuncture, creating targeted infrastructure hubs to heal stressed urban zones. Medellin had to build those hubs artificially. Bhubaneswar's temple node geography provides natural anchor points for the same social and ecological investment. This table maps global sustainability precedents against Bhubaneswar's advantages. It proves that every required element of the city's restoration has already been demonstrated at scale. The world's most advanced urban solutions are modern attempts to recreate what Bhubaneswar's ancient planners already perfected. This chart shows the title page of the Bhubaneswar Climate Sovereignty Doctrine, a scientific blueprint for the city's restoration by 2036. This matrix lists 8 quantified engineering commitments. They set measurable targets to cool hotspot temperatures by 3 to 5 degrees, restore 40% canopy cover, and achieve 100% water harvesting. This infographic details the 5 signature missions that will deliver the vision, including the 100 Lakes mission and the Sponge City mission. Executing this doctrine requires no new primary legislation. Under Articles 21 and 48A of the Constitution, the state already has a justiciable duty to protect the environment and improve public health. Restoring the green-blue infrastructure of this city is an engineering necessity. Performance is a mandatory legal obligation to every citizen. By 2036, the goal is a city that functions in harmony with its own geography. Impermeable concrete will give way to porous surfaces, native forests, and clean water channels. The doctrine asks citizens to take the EKAMRA pledge. Every tree planted is a climate shield. Every lake restored is a water bank. Every citizen engaged is a guardian of life. Every law enforced is a covenant with the unborn. For 25 years, Bhubaneswar has borrowed against its children's future. This doctrine is the repayment schedule. True development happens when nature leads, and construction finally answers back to nature.